Mr. Sean. Bob got roof construction questions for you, so
Yeah, we're later.
quiz times, solar stuff, you know.
Okay, I can bullshit.
But he's got to give calcs to the city, so you can just make the calcs look good, and they'll be fine. All right. Cool. So, hello everybody. Thanks for coming. So we do these monthly meetings. It's like a show and tell. People give project talks on projects and things that they're working on. Never been here before. And then after the meeting, I'll give a tour if anybody wants to. You can meet by the toolboxes back there and show you what's here or whatever else. Without further ado, we're gonna have Mr. Bob go first, I think. On apparently a demonetizing slide here, it mentions blowing things up, so probably gonna lose all of our YouTube things. Yes, thank you, Bob. Oh, what a professional.
Okay, where's my walk-on music?
Ooh, yeah. We could probably pull something from that.
Are you guys ready?
Take it away, sir. Thanks for remembering Zoom, people. I would have seen it when I got over here.
All right. Okay, so I'm going to talk to you about refurbishing an exploded grenade. It's not a literal grenade, but it felt like one. Well, I didn't feel the grenade part. Anyway, for the last few months, I've had some heavy equipment here at Sector, and I have been working on repairing it. So what we are dealing with is actually, okay, so what we are dealing with is a Magnatech E-Force power converter. So in a wind turbine, there's the spinny part, and that generates the electricity, and that sends the electricity down to the power converter, which then gets the electricity ready for the grid. And so, yeah, here's more of a description. So the hub spins, that spins the gearbox, which increases the RPMs, which then turns it into three-phase AC, and then that three-phase AC gets turned into DC, and then that DC comes down to the bottom of the tower and gets converted back into AC. And if you're wondering why it gets converted, I'm not entirely sure.
It's to synchronize it.
Oh, that makes sense. Yeah. Okay, so this is a block diagram of, or a schematic of what we're dealing with. So starting on the left side, we've got the generators, and then they're the rectifier turning it into DC, and then that DC goes down to the converters, and then it goes through a filter, and then that goes to the line voltage, or the utility. So what I'm working on specifically is the block that says DC to AC. And only, so in a 2.5 megawatt turbine, there will be 2 of these setups, and each setup has 2 of these DC to AC converters. And this is what this big machine looks like, the power converter. So there is a converter on the left side and a converter on the right side. And then the thing in the middle is a blower, which basically just blows air to cool off the IGBTs. And then there's, below that, there's the line filter, which takes the 3-phase output from the IGBTs and cleans it up. So this is what the bottom of the turbine base looks like. We've got the entrance and then the 2 converters, or the 2 power converters, each one having 2 converters within it. I'm not going to talk about this. This is boring. Okay, so yeah, I'm not going to do this one either. All right, so DC or AC to DC, you would start off with a rectifier, which turns all of their negative stuff into positive stuff. And then you have this kind of slightly wavy DC. So then you would put it through some filters and clean it up. And that's what the converter that I'm working on does. Well, yeah, does backwards too. Okay, anyway, sorry. So inside, oh, that's why I put this slide in. Sorry, I'm a mess. I haven't presented in a while.
Good, this is good.
Okay, so what the thing that I'm working on, it takes the DC and it dumps it into some capacitors. These are big, bulky capacitors that basically allows us to take this kind of wavy, messy DC signal and just give us a whole bunch of energy. And from that, we can put it into the IGBTs, which then give us a really nice, or a nicer AC signal. And then we put it through the filters, which gives us an even nicer signal. And then it goes onto the utility. So inside of the converter box that I'm fixing is a capacitor bank, which has a whole bunch of capacitors, and then 3 IGBTs, which turn our DC into 3-phase AC. And then there's a whole bunch of control circuitry. So this is what one of the capacitor banks looks like.
Definitely gonna answer.
Thank you.
They're really big.
Yeah, so this is one, and there are 4 banks of 10. So it's 5,600 microfarads. So it's quite a bit. And yeah. And and then the IGBTs, so they can only switch on and off. So what they're doing is PWMing to get you close to that AC signal. And this is what there are 3 of them inside of this converter to generate the 3 phases. And yeah, they're super big. Okay, so what happened was so I'm a subcontractor for a guy who installs wind turbine stuff. And what happened was there was a catastrophic failure, and Magnatech is out of business, like not in the wind industry, not in general. But so they're no longer making these converters, and there are a whole bunch of wind turbines that use them. So if there are failures, they have to be refurbished, or else the turbine goes offline forever, unless you replace the entire thing, which would be all of the electronics, which would be a lot more expensive. So it actually made financial sense to throw $10,000 at me to replace everything inside of the box and refurbish it versus having to replace the whole system. So this, I was able to find the service manual, and this particular part jumped out at me. Apparently, catastrophic failure is not uncommon for these things. And this is actually one of the nicer failures. The failure that I got to see was something completely different. So when it got delivered to me, and it's sitting over there, there was one that was good and one that was broken. And so the good one was helpful as a reference point so that I could make sure that I took it apart and put it all back to the bad one. I could take it apart and put it all back together. And it's sitting on normal sized pallets, so you can see just how big they are. They're like 4 feet tall. And this is what went wrong. So one of the capacitors exploded basically. And when it did, it shot out all of its electrolytes. And so there was a whole bunch of heat and smoke and I think acid that essentially just spread throughout this entire cabinet and damaged in some amazing ways. So like you can see, this is 1/8-inch thick steel that got bent like that. And then you can see all the corrosion on all of the heads, or all of the nuts. The inside of the cabinet, we've got, so this is called fish paper, and it's not paper, it's like some kind of plasticky thing that is supposed to isolate from high electric potential, but it just burned away, like especially on this left picture, it's just gone. And so there's fiber optic cables that either melted or just completely disintegrated. We've got in some places so this is where a snubber capacitor was, and was is really important. So like it melted the metal to the point that the capacitor just fell off. And some of the screw heads are just completely melted. Some of the threads were gone. Like it was just, it's a mess. So yeah, you can see the screw is just, there is no screw in there anymore. It's just a blob of melted metal. And that one capacitor wasn't the only one that messed up, because it sort of had a cascading failure. After that one failed, then the rest of them kind of went too. So basically I had to replace everything and clean everything else, because I didn't want all of this carbony, smoky stuff that had covered everything to stay there. I didn't, like, we're dealing with 700 volts and hundreds of amps. I don't want sparks. So I took everything out of the cabinet and started cleaning. And this is what it looked like before, and then what it looked like after. And this is a lot of elbow grease and soap and water. I started with isopropyl alcohol, but then just kind of gave up on that and just switched to water because it was just too much. The isopropyl alcohol wasn't helping that much, and water was just fine. I'm not worried about rust because afterwards I went and cleaned all of it up anyway. So yeah, I took everything out, cleaned the cabinet, and then started working on replacing all of the components. So fortunately, there were backups of all of the circuit boards. So I didn't have to source any of those. We had gotten those off of eBay or something. So those are all okay. But there were a whole bunch of other components that I did need to replace where they're either like, okay, so the capacitors, that was about $1,500 for 45 capacitors. They were not cheap. And they had to do a special manufacturing run for me. The snubber capacitors in the center, those, so I called up ASC, the company that makes them, and they wouldn't give me a data sheet, and they didn't have any of these in stock, and they were made specifically for Magnatech. So they didn't have, like, they wouldn't tell me even any equivalent, like, they wouldn't tell me enough of the specs, like the ESR. It's not on the label, who knows? So I had to, yes, Sean?
Sorry, but if Magnatech, they know that company's no longer in business. Is there still, and this is maybe a patent thing, or is there still like a relationship with that manufacturer and that no longer exists again?
Yeah, so ASC told me to go talk to Magnatech, and there was nobody at Magnatech to talk to. And there was just nobody. I tried for a long time, and the sales rep was kind of a jerk to me. So, because I'm only dealing with a quantity of 6, right? So he doesn't care. Yeah, so I ended up finding parts that were close enough, and I hope, like, there's the snubber caps don't matter as much, and so I found one that is specifically for IGBT snubbers. Like it should work just fine. The dimensions were slightly off, and the way that the leads come out, so I had to do some bending and stuff, but I found something that worked. But then I also had to source like the bleeder resistors and this hygrometer, and then the fiber optics. That was tricky too, because I had no idea who the source on that was. But I did manage to find a company that was able to do it surprisingly cheaply. I think it was maybe $15 for each of the 3 cables, and they were made to length, and it was great. But yeah, it took a while, like a couple months to find and source all of these replacement parts. And oh yeah, I had to get fish paper too, so that was a fun one, because again, I'm only looking for like 4 sheets, and so they were like, well, it's gonna be an extra $100 just for this small order because you're a small order. So it was slightly annoying. So I took everything apart, and like this assembly that you see is reassembled, but it is so many individual parts that I had to take apart and clean, like with a scrub brush and water and paper towels, and then replace all of this fish paper that had burned away. And this is what I had to use as a template. So like, in the process of taking it apart, you know, I've got this fish paper and I tried to flatten it out as much as possible and trace where I needed to cut out and then put it all back together. But you can see there's so much damage, and this is just where the fish paper was. Where there wasn't fish paper also got damaged. And then I had to like grind and refinish a lot of the surfaces. So this is where the snubber capacitors go. So I was able to like cut away the orange insulation that was coating the metal, and then brush it off so that it was a nice contact for the snubber caps. And I replaced all the bleeder resistors and a lot of the screws and nuts, but I actually didn't need to replace all the nuts. That was more of a cosmetic thing because the acid, when it burned everything, only applied to the surfaces that were not electrically conducting anything. So like, when I unscrewed everything, the insides were great because they weren't exposed. So that wasn't a big deal for me to reuse some of the nuts. And then replaced the control electronics as well. Yeah, that's the story. So now now this unit is ready to go. They're gonna pick it up and it will actually be a backup. So I don't know if it's like a huge, but it could be. I can't test it. So there is no way for me to power it up and make sure that it works because just going through the manuals, like this is just one part of this 7-piece block of machinery, and like the main control stuff is a completely different part of it. I would need like 700 volts just to be able to turn it on. It's not going to happen. So I don't know, but the guy who owns it was like, yeah, this will go under my insurance. You don't need to worry about it. If it works, great. If it doesn't, it's not that big a deal. All right, any questions?
What are you talking about solar in your house for when you go?
Yeah, I could just put a 2.5 megawatt wind turbine in my backyard. I don't think any neighbors will complain about that.
No, they hook them up with some real.
Yeah.
Fair, yeah.
That last photo, look at those two boards, if they had different components, you can rebuild did you make a new motherboard?
No, fortunately, there were spares of these.
Okay.
So mostly I just had to clean off the contacts, like the wires, those. So the wires, I cleaned everything for two reasons. One is because I didn't want any carbon that had built up to be electrically conductive and cause sparks and stuff. But two is I wanted to like visually inspect for damage on every part. So when all of these cables that you see, those were all like mechanically and electrically fine. I just had to get rid of that crap that was on the outside. So I could reuse those, but the stuff had built up on the circuit boards, and I was not comfortable reusing those circuit boards. And the replacements existed. So yeah, it was mostly a matter of taking out the bad electronics and putting in new, assumed good electronics.
Was there any way in your deconstruction and putting it back together to determine why that capacity failed, or anything that you could have done differently?
No, And, but it's an electrolytic cap, and those have a lifespan. So, like, yeah, I don't know what caused the problem, but it happens, and it was important to replace not just that one capacitor, but all of the capacitors, because if they have like differing life, then they will perform differently, and so that could lead one to fail earlier. So you just start over with all new caps.
You're saying is you got a bunch of like questionable capacitors for a project?
Yeah, if you want to make a railgun out of these, you could hurt someone.
It's most likely yourself.
first.
Yes.
So I think we talked a little bit about whether you could install a shield to try to protect parts of it from exploding capacitors in the future. I think you remember you said there was airflow that you have to worry about.
Yeah, so no, I have not, because like there's that blower thing in the center that blows air onto the IGBTs, and so those are and there's like a heat sinks on all three of them, so those are getting cooled that way. But then there are also these tubes. Yeah, there. So you can see the tubes that are blowing air onto the capacitor banks, and so there is nothing that is blowing air back onto the fronts of the IGBTs, onto those parts. So I don't know about how the airflow is supposed to work in this thing. Maybe these things they probably won't get hot, but still, I don't want to put too much of that fish paper in and block things from getting airflow that need it. I figure I am not the engineer who made this, so I should make it look exactly like the one that we know works, rather than putting in my own hacks. Yeah.
You said I'd have another one of these to repair what you do again, or
No, absolutely not. No, it was just too much elbow grease and attention to detail. Like, I don't think that there are many people who could do what I did, because it required so much focus and like paying attention to every little thing, because it's hundreds of volts and hundreds of amps, and so any mistake, like if I miss one wire, then the whole thing could blow up immediately. And then, so like it requires a lot of focus and attention, but also it's just like scrubbing. And so like I'm making $150 an hour to scrub. Doesn't make sense. But yeah, so it is in alignment with my values to do things that make like renewable energy, but also it's not really in alignment to like scrub. So yeah, I would not do it again.
So practically when these fail in the future by the hundreds, they're just gonna probably replace the whole electronic package or retire them.
Yeah.
As your market opportunity, Jim, you can start building control cabinets.
Right. Well, the tricky part is going to be like these electronics and the other control stuff. Redesigning those, because like yeah, you can fabricate a piece of metal, but having to reprogram or redesign all of this is not going to be easy.
But assuming some vendor is not making them, it's renewing for them.
Oh yeah,
Not these.
Yeah.
Is the modern approach any different?
I don't know. I haven't gotten to work on any of those yet.
Any other questions for Tom?
Yeah.
So way back in the beginning, we talked about AC to DC to AC.
Yeah.
I said synchronization, the frequency is 60 hertz.
It needs to be grid synced. So the 60 hertz in the grid needs to fit. If you introduce your current in this thing opposite the grid, you'll pull this up, or you'll blow up in your small grid. So it's less power.
It's not only the frequency of the grid, it's
Yeah, yep, so it needs to be on frequency and time.
And it's
So-
3-phase too.
Yeah.
So all three to manage.
So whatever comes down, because if the wind turbine speeds up and slows down, and speeds up and slows down, it's not synchronized. So that's why they just rectify to DC. And then for the current out of the DC. And it's the same thing like our variable frequency drivers on any of the fans here are doing the exact same thing. They bring in the AC wave off the grid, they rectify it to a couple big capacitors, and they chop it and regenerate 3-phase AC at very frequency. That's how every VFD works. It's the same thing.
You face because of 3 blades.
No, it's a grid power. Yeah, the 3 blades in the turbine is cavitation.
All right.
Cool. Thanks, Bob. Cool. Peter, you want to take it away on the capitalist greed side of things?
Sure.
I figure we can alternate, you know. Let's go ahead together.
I'll just follow up.
Yeah. I think it's this game. Yeah, you do.
Hey everyone, I'm Peter. Nice to meet you all. I just finished a Kickstarter for a business I'm starting to sell pickleball paddles, which I started up here in Sector 67. So I'm just going to talk you through. I don't have any slides prepared, but to talk you through what my process was and what kind of inspired the project. So I started playing pickleball last October and went to go buy some myself and was not very impressed by what the offerings were, and they're also pretty expensive for what you were buying, which is like basically the most kind of basic ones. Well, the most basic ones are wooden, and that's what they used to play with, but the last 20 years they've kind of evolved since then. And the ones that you can buy from like, I don't know, say $30 to $50, have a plastic polypropylene honeycomb core material, and then it's fiberglass on the faces. And that makes it really like stiff, so it doesn't deflect, and then it gives it that like pop the ball. But just thinking of about that, I was thinking we're buying like 8 ounces of basically plastic and fiberglass for like $50, and so I was thinking, could there be something else better out there either? I was particularly thinking about sustainability, and is there a better material selection that you could use to get still good performance? So I was thinking about using bamboo as at least some part of the paddle, and that kind of kicked off my exploration is to see did that work for the paddle construction. So you can see the final product here, but I can scroll down to some prototypes that I made. So I started off just like looking to see if solid bamboo, how that would perform relative to existing paddles or even to wooden paddles. And part of what I ran into is that bamboo is more dense than the plywood that they use for wooden paddles. So the thickness was relatively thin, and then bamboo also absorbs a lot of the energy of the pickleball when you hit it. So it wasn't given as much power compared to the standard paddle. So then I was doing some tweaking to figure out, okay, what can I use as a core material? And I tried the same plastic polypropylene honeycomb core that they use with the fiberglass faces, and then the higher ones use carbon fiber. But I found that the bamboo is kind of a similar effect. It absorbed a lot of the energy still of the ball, so it didn't provide the same kind of power that you get with your normal paddle. So then, looking into a couple other potential core materials, I landed on a foam that goes in between the shoe. Sorry for those who are on the Zoom, you won't be able to see the, yes, what they would tell, but, so I ended up, sourcing some bamboo veneer, that I laser cut to the profile, and then do the same with the foam core. And I found that when I sandwich these together and, glue them together, it actually gives some really good performance because that foam, it's a very stiff foam, but it once you have it together, it gives it a little bit of bounce, basically, the energy of the ball. So that helps to balance out the fact that the bamboo likes to absorb some of that energy. So then with that, I kind of fine tune like the density of the foam and the size of the handle to make sure that it had enough strength in terms of the deflection, and then also trying to get as close to the weight of current paddles as I could, so that if someone picks this one up, it's definitely going to feel a little bit different in terms of how it plays, but it's going to be a pretty seamless transition once you play with it for a little bit to say, hey, this could be my go-to paddle. So then once I kind of figured out that aspect, it was, sourcing some of the other components like the trim that goes around the paddle, the grip, and then I'm doing like a bamboo end cap as well, just to kind of build that sustainability story. See it on here, or here, instead of using more plastic like they do for tennis rackets or other pickleball paddles, just using the excess bamboo that I get when I cut out this profiles to create those end caps. And so then it also gives me the chance to do some fun like engraving. So in this case, for my Kickstarter, I have a tier where you can choose to do your own initials on the end cap. And then I do engrave the logo here. So yeah, so then the other fun part was coming up with the brand. I'm an engineer, my background is engineering, I'm not marketing, so it's kind of fun to dive into that part of the projects, come up with a name for it. And I have a friend who's a graphic designer, so he's helped me out with creating the Sun Rally brand, and creating a lot of the graphics and stuff for the company. And so we kind of made a website and sent it to just so this is not live yet because we've been focused on the Kickstarter, but you can see like the goal is eventually to yeah, we launched this Kickstarter to basically raise the money to buy all of our materials ahead of time, so that we didn't have to kind of like put the money up front to buy the materials and then try to go get orders. Set a goal to raise $10,000 to go and be able to buy larger runs of the material from the different sources, and then build a bunch of paddles for people who pre-order them basically, and then get the paddles out into the world, hopefully spread a little word of mouth marketing, and then give me some extra inventory to start selling on an online store once those Kickstarter rewards get fulfilled, and then we'll see from there. That's the next step would be figuring out, do I want to find some stores, some retail stores to just try to sell it in more like picking more like local stores or like sporting goods co-ops or things like that. Kind of sustainability story. So I guess the other part about the construction that I didn't mention is I decided to 3D print the grip slot that goes on the end of the handle. I've been using balsa wood just doing prototypes because it was easy to just kind of quickly mock up to my shape that I wanted to try with some different geometries. But then for long term, I was thinking, well, it'd be better to have something that gets this consistent every time and try to minimize the cost. So I got this material called lightweight PLA, and it foams when it prints. So it's kind of interesting. It reduces the overall density of the part then. So first help me print those out and fine tune the settings to print a bunch of them for the paddles, and basically that goes on the paddle face here, and then I use heat shrink tubing over the top of that to basically pull that together and then encapsulate the bamboo habitat, and the grip goes over the top of that. So this is kind of those are some of the final details. You know, the main focus was figuring out the bamboo and core structure performance, and then it was just kind of will be the more mass production ready type components. So yeah, so that's kind of the basic story, and I'm starting to. I finally got all the material yesterday, and I'm starting to do a bunch of laser cutting around. I'm going to start doing a bunch of laser cutting now over the next 2 weeks, basically, and start assembling them. And just assembling them myself for now. I have about 150 to make for the Kickstarter, and then we'll see as it, hopefully expands from there. We'll see what the longer term plan is. So, any questions? Yeah, go ahead.
Your thing says delivery in November. Are you going to be the first Kickstarter to deliver on time?
Let's hope. I gave a very conservative estimate just in case anything came up, but assuming I don't run into any major hiccups, I should be able to meet that timing. So I think a lot of my backers were friends and family, so I also feel like, on one hand they cut me some slack, on the other hand I know them and I deliver on time to them. And a lot of them are normal Kickstarter backers, so they don't know the track record, I guess, with Kickstarters. So, yeah. Go ahead.
I'm sure about some bamboo wrapped
Around the handle?
You could make a handle out of bamboo.
Oh yeah.
Like bamboo strip.
Yeah, you mean like this block here or the actual grip? Yeah, I think that could be interesting. I think it's the idea for now is sticking towards what people know and are used to for multi-plywood, but yeah, that could be an interesting longer term project. So I kind of said in my Kickstarter, like, it's definitely a step in the right direction if you're like, interested in sustainability, because the bamboo is better than the fiberglass base. Obviously, like the foam itself is not, it's still petroleum based, but what's that?
or use one.
Yeah, yep. Or like foam, other things. So, yeah, so I think I said there's some future, opportunity to continue to improve if I want to make it more sustainable or great. Yeah.
I'm curious, I missed the edging detail.
Yeah.
Is that a custom material or is that a stock that you were there?
It's I ordered from a guy in Canada who makes paddles as well. It's just a thermoplastic that's extruded in just long rolls, and then I just cut it to shape, and then it actually does a nice job just like conforming to the profile once I use super glue to glue it down. So I just had to find a guy that had the right, geometry to fit the right pedal thickness, but then it's just so it's good.
Probably pass it around.
Yeah.
We've got a reasonable track record of not just fans. So I'll give it to them.
These are really good. So.
So how many hours of product testing you got on?
Like physical play?
Yeah.
Probably like, I don't know, 60 hours between the different people that play with them. I definitely still am hoping to fine tune it after I get the chance of a few more people, especially like people who play. I'm part of what the next step is figuring out, like, is my target audience, like, my thinking with the branding is like people who play for fun, not necessarily people who play in like tournaments. But I'm curious to see like how do people who play really competitively, like the performance versus kind of finishing your
So
panel.
speaking of, are there rules-based restrictions on panel design?
There are, yeah. So there's like USA Pickleball Association rules on panel design. So it covers anything from like the width and height of it to like the deflection, like I mentioned, or the surface roughness of the face of it. So my construction is probably, as the rules are currently written, probably won't get approval from this body if I were to submit it for approval, because the foam actually gives a little bit more face deflection than what their requirements are. But the debate going on in the pickleball world right now is, you can imagine this, it's a big, explosion, is that they basically, that test method is to measure if there's a trampoline effect to the paddle, because if it's obviously like deflecting and rebounding, like you can give more power to the paddle. But it's not, they just do this by putting like a certain weight on the face and see how much deflects. But that doesn't actually reflect like the actual power coming out from the paddle. You know, if you put Play-Doh like underneath that, it's gonna deflect, but it's not gonna, well, maybe Play-Doh helps you know, but like you can get the point. So now they're talking like, well, do we need to update the rule so that you actually measure like the exit velocity off the paddle face, like you do for like a baseball bat, for example, like court bat versus a bat.
That's gonna be the next question, if you consider it a court line.
Hey, that's I like that too.
Sustainable.
Court, sort of, yeah. So it's sort of, so
Does like a commercially made pickleball paddle have the same width?
yeah, yep, they got that same edge guard. Well, most of them. I guess there's some expensive ones that are like thermal-formed that have like a seamless edge.
Or just said not like good effect performance of the ball.
Yeah, no, if you hit the edge, that's kind of what you see what other paddles do. Yeah. I should have brought a ball to you guys. Put it on the towel, but,
As someone who has developed the sensitivity to super glue while working on mass producing a product,
yeah,
definitely do some kind of protection.
okay. Like you mean like ventilation or?
Yeah, because now every time I'm exposed to super glue, I get like replacement.
Oh, wow, okay.
So it sucks.
That's good to know.
Admittedly, Bob was swimming in super glue, maybe slurry for like a couple weeks, but the point is still well, very.
Yikes, yeah, okay. I'm open to other ideas too, if people have alternative to super glue. That is the problem with what I needed it to be like quick setting, right? Like, so I tried epoxy, but it just took too long for it to actually like.
There are hot melt adhesives that may,
Okay.
like automotive industry, construction users will do for, and they're basically like a fancy hot glue.
Okay.
But they have like 3-minute open time, 5-minute open time.
Okay. When you say it's hot melt adhesive?
Yeah, if you search for hot melt adhesive,
As a
you still gotta work fast. It's like hot glue.
Right.
So the only time I would recommend a YouTube video person, but somebody on another hackerspace posted this video this week. It just came out, and they basically discusses a whole variety of different respirators and their effects on sawdust, and then also on organic volatiles. So he's essentially just got this big ass syringe and then a box below to draw in off this mannequin head. So it's like a CPR mannequin. So it's a clever way of building an interface for a CPR mannequin. And then in this box, he's got a PM sensor as well as Vol Organic, basically like an atmospheric quality sensor. And then he can swap out different masks and get different effects. And so essentially, this is inside the little polycarbonate box at the bottom. But the moral of the story is all of the stuff that we do generates shitloads of particulate. Which is why we have all the exhaust systems in the shops trying to minimize that. But remember if there's anything much more about it. He was also doing some long-term like residuals in terms of just how long some of the stuff runs for. So this was running one of these little tiny desktop laser cutters. And so he's running this, and then you can watch this thing just peg. It takes a couple seconds to basically peg out. And then the catch was he came back the next day and it was still reading over like the OSHA safe whatever, just from the ultra fine dust that's produced by laser engraving.
And that PM 2.5 is the same, like when it was 150 or whatever, it's basically debilitating. The $9.99 is.
It's problematic. But anyway, he shows a bunch of wood finishes and discusses just like, even though these wood finishes say 0 VOC, they're actually not 0 VOC. And he's getting measurements anyway that are, you know, measurable coming off. So anyway, long story short, yeah, it was the hidden dangers of DIY. It was worthwhile watch. Well, I think Scott's gonna close out since I'm already up here. I was very short time. Sorry. Thunder. I have a very short talk on fixing the beverage refrigerator in the kitchen. So, like 5 years ago, we bought this building, and Eric and I, we already had tons of stuff in here. Not that we don't now, but we did even then. Amazingly enough, around the corner there was somebody who like rolled a big stainless steel like bar refrigerator out to the curb. And so we had the big flatbed we were driving stuff back and forth with anyways. And so Eric used to do refrigeration. He's like, we should grab that thing and make a great soda fridge for the shop. So we grabbed this thing and of course bring it here, and it sits around for like a month or waiting to do another construction stuff. Finally got the kitchen built like around the refrigerator. Plugged it in, it of course didn't refrigerate. But it runs R134A, which is the same that you can get for automotive AC systems. So it's nothing special on the refrigerant side. So we recharged it and it ran for like 2 years and it was fine. We were like, who knows, you know, I wonder why somebody threw this away. And then sure enough, 2 years in, the charge went low and it died again. So I recharged it and it lasted like a year. And then I recharged it and it lasted like a month. And I was like, God damn it, there's a leak. So I should have grabbed it down. I don't think I've gotten this picture. It's actually hiding behind here, but these are the basic tools you need to do refrigeration repair. So we could become our own HVAC specialist with very few tools. This is an automotive gauge set. So it's the ubiquitous kind of dual gauge, high-low refrigeration gauge set. It allows you to see pressures on both sides of the pump that's in the refrigeration system. This red handled guy here is a vacuum pump. It's just a Harbor Freight. It's a reasonably decent vacuum pump. And then the thing I had to buy is this nitrogen regulator for a nitrogen tank. Whenever you want to open up a refrigeration system, you have to have clean, dry gas inside, or else when you're heating it, you'll get a ton of oxidative growth inside, and it'll clog the filter that's in the loop, and it'll also destroy the pump. So it's really important if you do try to do any of these repairs that you have to put nitrogen inside of it. Otherwise, you'll immediately build this huge amount of oxidation, burning the oil and the refrigerant that's inside of it. So long story short, I hunted around with a fluorinated detector, so it detects the fluorines that are in refrigerants. And so you can hunt around with this detector and it beeps at you whenever it detects these refrigeration compounds because they're super rare in the air normally. So it's pretty sensitive. And anyway, it went off inside the cabinet where the cooling coil is inside of the cabinet where the refrigerator is at. So this is on the condensing side. The evaporator's outside, condenser's inside. At any rate, what happened was when somebody at the factory was manufacturing these things, this thing's about 10 years old. Whoever was making it, there's two ways to run an oxy-fuel torch. One is with a reducing flame, which is where you have excess fuel, and the other is with an oxidating flame, which is where you have excess oxygen. If you run an oxygenating flame against something that can be oxidized, it will promptly eat it because the oxygen is super reactive and you're making it hot. So if you look at the surface of this pipe, it's all pitted. That's because whoever was at the factory that day set the torch up wrong, and every single unit that they brazed that day is going to have this huge amount of oxidation on the unit, and they basically trashed every single one of these refrigerators. Obviously, it worked just outside of warranty, which I'm sure is perfectly convenient for the company. But in our case, what happened was there was a number of little tiny pinhole leaks on here. So I grabbed the smallest torch we had because I couldn't. I mean, one way to do this is you pull this whole system apart, and then when you do that, you're brazing this little tiny tube in. It's called a capillary tube, which is the way you normally install one of these. In our case, we're doing repair work, and so I don't want to pull this whole thing apart, replace the capillary tube, do a bunch of work, and then fix it. I just want to blob some braze on and repair the spot that's leaking because I'm lazy. The catch was my torch was too small, and so this is a little tiny jewelry torch. So I tried heating this up, couldn't quite get it hot enough to get a good braze seal. And then the other challenge is because I was running nitrogen as a back gas, is what it's called, on the inside of the tube, flowing nitrogen. I turned down my nitrogen bottle to what should have been a brazing pressure, and then flow that in. But because the system's sealed, again, normally the system you'd have open on the outside of the system. So you braze the little tube inside of here, then you go out of the refrigerator and braze the big tube on the back. That's the way you're supposed to do it. I didn't have that, so I had this little teeny tiny hole, and it turned out every time I tried to heat this up, it would boil up, and it would boil out and boil out because the nitrogen had nowhere else to go out. And that was even when I shut off the nitrogen, and it was still boiling out. So there should have been no pressure in there. I finally pulled the valve seal, the valve core on the system, and it dumped a whole bunch of nitrogen pressure because the refrigerant's already all long gone. Which means that our system, the capillary tube, is basically barely allowing the nitrogen through. So it's accumulating pressure in areas it shouldn't have from a purge perspective. So long story short, there's high pressure on this side, even though there's no pressure on the output side on the other end. So what I ended up doing was pulling the valve core, brazing it without nitrogen flowing, but the system's still full of nitrogen because I filled it for like 3 days. And so it should be fine. The fact that it's still running says it's fine, but and then tried and true. What's better than brazing or welding? JD Weld, obviously. So what I did then is I had to recharge the system anyways, so I pulled a vacuum on the system for about 24 hours. And while I was doing that, I blobbed a bunch of JB Weld on here. So even if there is a leak still, it would have gotten vacuumed into the tube. And so it should theoretically see all those little tiny pores that are all over the place, which will eventually otherwise start leaking. The other thing is you'll notice that the whole evaporator is coated. So they have this epoxy coating on everything, except for where it's brazed. So that's the other thing that this company could do to make this last a lot longer is if you coated this thing so it wasn't exposed to moisture cycling, this would probably not corrode for a really, really long time. Proofs of the pudding, it still runs. I don't know, I'm definitely not an HVAC expert, but conceptually speaking, we have all the tools to braze a thing for a house or whatever. The only challenge is there are regulations around who can buy and install refrigerant. So this refrigerant's unregulated. It's the same thing that goes in cars. They dropped the regulation on that a long time ago. But if you had like R12 was an old one, you can't even buy that stuff. It's super expensive. It's also terrible for the atmosphere. So there are some things that you can and can't do. Interestingly, getting a refrigeration license is not super complicated. But long story short, refrigeration 101. Any questions? Yep, sure.
You made a wind-up refrigerator, which you did a license somewhere.
We made a wind-up refrigerator. Like literally wind?
Yeah, you wind it up. It's cool.
If you could figure out the physics of it, you wouldn't need any license to sell it. I don't know how it would cool, but I suppose if you got something wet and spun it really fast, you could cool it down. John?
So, well, one, is that the last time you're ever gonna be able to fix that? Another about JB Weld, where it might be.
Very good question. So if I do have to fix this again, what you do is you cut this off. You get a hole saw with a guide, so you put a dowel in a hole saw, and you cut this metal steel frame off with a hole saw, and then you peel back these fins and you clean this new copper up because we know the copper is good underneath the epoxy coat, and then you put a new capillary tube in. And you smash this down and you do it correctly. So this is Chris's punt at fixing it as fast as possible. Followed by Chris is angry and has to rebuild everything, and then you do it correctly. You take a little, like an inch off the system.
And then do you have to charge it with the identical refrigerant because it's designed for the system, or are there other?
There are other things you could recharge with. The actual problem is not the refrigerant, it's oil compatibility. So the pump can generate a pressure differential, but if you have an old R12 system, for instance, and you try to recharge it with a new modern refrigerant, the oil congeals. So you actually have to purge the oil out of the system and then refill it. Joe's in the compressor, which is the wrong way up, so you have to blow a bunch of gas through it to knock the oil up. And then you can clean the system, and then you can replace the oil, and you can put a new modern refrigerant in, and use the same pump, because the pump's just generating pressure. So, no, Aaron, I'm not doing commercial refrigeration for Qualmos.
No, why didn't you just use some of that silicone wrap?
I will be honest with you, I did look up.
That would have been like the fastest, quickest way to do it.
There are cold weld products that are sold for HVAC technicians to like repair your AC or whatever. So if anybody's ever selling their house and the air conditioning doesn't work, just get out there with some of the cold glue and just glue it all up. But I looked online and read reviews, and like the reviews on the company website are stunning. This thing works great, yada yada yada. If you look around like on forums and places, people are like, yeah, I tried that. It worked once for about 2 days, and then it started leaking again.
Well, I mean, if you like double, triple wrap it.
Yeah.
Well, that's, I mean, it stretches really nicely. That creates a great vacuum seal.
It's the problem is it's under pressure. So even when it's running, it's at about 50, like 30 psi.
Is it?
When it shuts down, it goes up.
Vacuum or
pressure.
Oh, okay.
Yeah, so it would pop out.
Yeah. There's also that infomercial stuff.
Mr. Park? No? Alright. Is that what you're asking this,
No, I
Aaron?
was asking, not that Aaron's question wouldn't have been good, but I was asking John. But
So- The other two fun things to know, the whole industry is going away from brazing. So they don't braze stuff anymore, they're crimping everything.
well, there's O-ring in the refrigerators, or?
Yeah, like AC systems. Yeah, like for your house, the line sets are going to a crimp product.
But the actual seal is still.
I think it's copper to copper, just like the foaming ones.
Well, the plumbing ones have.
Do they have O-rings?
Yeah.
I don't, we have to see. Anyway, they're going to a print product. The other thing is Loctite sells a product that's a slip fit. It's like a very, basically like a Loctite glue product, but it goes in and you have to make a big coupler joint. So that's one mistake the HVAC guys are using, is they're using that as like a cold repair when it really needs this big like socket to glue together, because it needs a lot of surface area so that it's stable.
One of the interesting things of this, I think there was a special alloy for the brazing that was like a HVAC kind of braze alloy that.
I used whatever Lon donated to us upstairs, so
never mind.
it's a copper to copper brazing alloy. What you're supposed to use is silver something. It's 15% silver, so it's very expensive alloy because it's high silver content. And that gives it the flexibility across temperatures, which is the other reason you're kind of screwed on a cold product, because the temperature on this thing swings like crazy, and it's wet, so you got a lot of strange difficulties with that. Mr. Scott, you want to take it away?
Alright.
I mean, don't get too comfortable in the rocking chair. That's
Hi, my name is Scott. I'm a member here and I do various things. Been involved with some of the construction of this building. If you know the story of the organization, you know the building that we're in is basically our biggest DIY project. Along with that comes our hacker nature, which is to get into and understand various levels of details of things that you probably never really thought about. And what I'm going to talk about today is our back stairwell handrail. So you probably have walked by and used handrails hundreds of times in your life. Never thought too much about them necessarily, but there's a lot of thought and engineering and fabrication that goes into a proper commercial handrail. So our back stairwell is what they call a dogleg stairwell. It goes up and has a platform and then goes up again. And so first I'll talk about some of the constraints that are around in the code of doing a handrail properly. And you might think, well, what's the big deal? But handrails are actually an integral part of accessibility for a facility, for a commercial facility. They need to be graspable. People that have trouble seeing need to be able to feel their way down. They obviously provide support for people that need support. And so this is a page, you know, Chris and I went through the various codes that apply.
And Sean,
Oh yeah, and Sean also helping for this. Here's 5 constraints, and there were some more constraints that matter. But so any handrail you see in a commercial space should be between 34 and 30 inches high, off of the slope of the nose of the stairs. The handrail diameter matters a lot, so we ended up using, in the spirit of reduce, reuse, recycle, we used 1-inch gas pipe that was salvaged from the original building, which is 1.31 inches outside diameter for the actual rail itself. These are the angles that we use for the support, which were salvaged out of they were the diagonal supports on the outside wall when we originally inherited the building, bought it. And the plates that we cut, Kate Baldwin, I know her, she does a lot of design for projects around here, but we needed some architectural flair, obviously, for all the custom work that we do, and so she designed a series of, these are the plates that go on the wall, with that angle sub welded in to those, and we plasma cut those out of a panel.
it's a recycled CO2 laser cabinet.
Recycled CO2 laser cabinet. So every part of that stair actually was reclaimed
From the building.
from the building, yeah.
Taking out like pieces of the roof that you can start worrying about.
Yeah, so the handrail needs to be graspable. So there's not only if you use a circle, there's a diameter that matters. If you use a other profile, there's an equivalent sort of diameter that matters. You need to have clearance on the handrail, can't be too tight to the wall. It needs to be an inch and a half minimum, and you sort of see these fun, the fun kind of curve following the column there. We have some things like that. They need to be clear of maximum projection considerations as well, so it's not too far out. And then there's some minimum distance sort of things, and then also clearance below to the support from the stair rail there. As you come up to a landing, you need to have at least 12 inches of extension into the landing. The rail needs to go back to the wall, so you can't get hooked on the railing as you're walking toward it. So if you're ever in a commercial space and you're approaching a stair rail, you'll notice it goes either to the wall or back down to itself. There's not a way, if you were walking with something with a strap, it wouldn't get caught behind the handrail. That's by code. And then on the bottom of the rail, it has to extend for 1 full tread more through to the floor. So we have a 7 to 11 slope on our stairs, roughly. And so ours go down 1 more, 11 inches out on the stairs. So our first job was to understand all of the code that applied to where we're at here. This is the 8th one to the left. And then we did a little bit of a we did Fusion has a Fusion 360 as an Autodesk product for computer-aided design. We did a design that isn't to scale with respect to the lengths of the pipe, but it was to get a sense for the architectural detail of the thing that we all agree on kind of what this thing was going to look like after we had it built. And Fusion 360 has this really nice, you can do a 3D sketch of a line and then you can put a pipe onto it basically. So we didn't have to really do anything fancy with any of these.
Can you rotate that stuff?
I'll try. It's really pokey on this lap.
The coolest piece.
Oh yeah. Yeah, so we had to wrap the columns in fireproofing, and so we have the column protrudes into the stairway a little ways, which means that we have this interesting piece of detail here. We're going to come back around. So then we have the theory of the stair rail, which is great. And then the theory meets reality means a lot of fabrication. So this is the piece we plasma cut the designs out of, and there are a lot more than what I showed there. And here you can see the pieces I'm passing around, some of them. The layout was pretty interesting. So we had to find studs, obviously, in the wall. We got steel studs back in the stairway. Find studs on the wall is not straight. So we found studs where the supports would go. We made a line, basically a string line, measured each one of the distances from the wall out to where the rail needed to be, given the constraints around too far, not too close, too far. And then custom cut the angles like we were passing around to be able to be at the bottom of the rail for support. Welded those in, plug welded those into the supports, mounted them, and then basically worked our way through. So here you can see a chicken with some of the chicken wall plate with the support plug welded to a pipe, and then how we tied it back into the wall for one of the pieces. Some more of that. And then so then we worked our way through basically fabricating piece at a time, measuring, cutting, welding, sometimes remeasuring and fixing our way up around both sides of the stairwell for two handrails all the way up. I'll take on a little virtual tour here. There you can see looking up to the top of the stairs there. And now these are all we made it in smaller pieces in the welding fabrication shop, and then we moved those pieces in. But eventually, we actually have now just two fully, two singular pieces all fully welded to each other in the stairwell. Another piece of the code is that the rail needs to be continuous. So you can't have more than less than a 1/8 inch radius on any of the pieces. And there, yeah, you can see how the span creed on this one. And made it somewhat. We made a straight rail. We offset, so the distance varies quite a bit above the span creed, below the span creed. And then there, yeah, you can see that's the money shot right there. It looks kind of like the vertical diagram, right? So it goes up and around and then ties back in. Yeah, so it was, a miserable fabrication project, I think it's probably safe to say. But we got it in place. It's Sunday we got it in place finally. Chris called for inspection Monday and we passed the flying colors. So mission accomplished on the stair rail for the back. Any questions?
Did you use a real saw blade?
Well, it's supposed to not be sharp. So on the one that went in, I actually did sand it down a bit. The tools we use, so most of this is MIG welded, a little bit of it was TIG welded. We use the punch to punch out the bigger hole on all of the plates. Otherwise, it was drilled with countersink. The new belt sander in the welding shop is, I think, one of my favorite tools now of all time. That thing is just amazing at taking off material. Such a pleasure to use. So we use that a lot as we were. I share. In terms of coping the pipe and getting the angles right, I used an online generator to get the coping angles, and then I would use those templates on the pipe to set the angles as various angles depending on where it was meeting. I finally ended up innovating this, so that would clamp with a pipe clamp to one of the vertical supports, so I could set the pipe in, and then adjust to make sure that the angles were meeting right before I would tack weld it together. So that ended up being too late of innovation for me, but then all sorts of wood jigs as well to make sure that the offsets in the wall are right. So square. Thanks to Kate for various designs that ended up getting used. And yeah, a lot of just measuring in place. You can sort of think of it, the way I laid out a lot of it was just on the stairs. I laid out thinking about the center line of the rail on the stairs and over, so I could measure the stairs and then just project it out to the wall. But that works for the most part, but there were a couple of times where it was maybe 3/6 inch of a gap that we had to fix with welding. Yeah, so a little extra detail there. Yeah, any questions on that?
Was there a final weld at which point this can never come back out of the stairs?
There were one weld on each side where it's now will definitely never. There's no way to get it physically out of the stairwell without cutting it. We're good at that though.
Oh, that sounds like a challenge.
I didn't foresee any use case where we needed to take these back out of the stairs. And it actually is really nice for strength. They're really solid, and I was really pleased with how well it worked out. From the strength perspective, by code, they need to support 200 pounds aggregate, 50 pounds kind of anywhere. So we're easily doing that, but I think the full well means that this is the full support.
So it just has to be stronger than the car.
Stronger than the car lift. Oh, yeah, exactly. I think there we got this.
What are the fractions on your cooking jigs?
That was just I marked 90 and I marked 90s around. The fractions were from the template that if you wanted to measure it out, they gave you the lengths at various points around the circle. And then it actually wasn't that helpful. Oh, it's those times. But I cut an aluminum can and then laid the paper template on so that I knew I was going to be sanding with that on there so that the heat, and you can see on those the heat came through a little bit in some places. Or the port band was really helpful. get close, and then the sander to finish it. Other question?
The fact that you shaped like a slum.
It does not, and in fact, this stairwell, we're gonna do, probably a more traditional handrail. You can have different profiles, but it has to be gravel, so it wouldn't have to be a cylinder necessarily.
But yeah, they define the grassability, I think it's 6.25. So like, and they measure that from like, you go around the diameter. So like you couldn't do a 3-inch pipe, for example, because you wouldn't be able to get your hand around it. You couldn't use a 2x4, that's too big. But you can you could soften the edges of 2x4, so you could grip it with your fingertips, and then that would be graspable. So they've thought a lot about, I mean, this is one of your number one places.
And actually, as a background of this project, we had salvaged
Yeah.
railing from Zion Church that we were gonna use it, and life was gonna be good and easy. But the railing we salvaged from the church was not compliant with the rest.
1968, when they didn't care, little kids could fall on the stairs.
It was made out of this material. It's organic material wood. And, so we ended up going with
Well, you painted your metal anyways, it could be wood, you never know.
What is it, metal organic?
metal, I guess, is organic.
Do you make a round shape with a ball bearing or a ball?
Can you say again?
You make a round shape like a ball.
Yeah, I mean,
As long as it never got too thin.
Well, the radius would kill you, because it's, I forget the radius, like an 1/8 inch. So you wouldn't be able to make a ball chain, but you could make like a convoluted.
But if the balls are, if you took a bunch of spheres and welded them together.
Yeah, and they'd build them.
yeah, I guess that'd be the grassability question between the balls. I don't know how they would treat that. It does need to be smooth, so maybe not, or, yeah, it needs to be relative.
That's why there's exceptions to all the code book rules.
Yeah,
Ask for a variance, then they.
Although that would be a really slick way to get around these corners.
it would,
You
you
just
just
did a
sort of
bunch of
lay them
spheres,
out
like
like this,
each of the
tack,
spheres,
tack, make it track the.
But we gotta do the people.
Yeah, right.
Cleaning, what's that?
So there are parts of the rules that were added to cover skateboard.
No,
That's
I,
anti-architecture.
we have it nice and smooth. Someone brave.
Alright, we got one last presentation from Adrian. It's, talking about building sign. We're gonna cover it all. We actually, yeah, it's very hard to switch, because it's, streaming on here. Maybe we can figure it out. Because there's no way to share it to anybody online. Yeah, that'd be the easier one. If you have you just because it catches the people on here can see it. That's fine. I just saw this.
I know, it could be a great one. Actually, by the time I got it, I'm like, oh, this is bad.
Eight 3912.
And nobody asked, but I think that aspirationally that'll be the last handrail project I ever. I know we've got one more. What a pain.
1, 2 weeks. And I'll steal, yeah, and I'll steal this from you. That way, bros can see it. You just hit join. You can mute. Seconds, bros can see. See if you can break Zoom yet. Because it'll be,
15 minutes, are you paying?
I'm paying you?
No, you paying soon?
Oh, That's all Scott. Scott's on. Scott's got the fancy suits. So looks like we should be good. Zoom bug. That's cute. It's as big as the screen gets, sir. It'll survive. That's because it took the graphics down and back up again. It's a graphics. I mean, I could close Zoom, but I don't think it's gonna come back.
Okay.
Looks good over here.
Okay. Hello, my name is Adrian. I am a Sector 67 member for more than 10 years now. Yeah. Well, I have a side business now. I'm designing signs, and I want to show you what I was working on.
I have a delay to.
So a company hired me to reclaim this sign, to replace the copy. Now I have a license. I did all the exam to be legal to do these kind of things. So the client gave me two concepts because she was trying to hire another company and she asked me for help because she didn't like the design. She gave me this design. So I helped her to put two designs into reality. So this is part of the process that I was working, trying to put a tree in a sign. And this is the final concept after going back and forward with different colors and different tricks. Well, I did this tree design, but I needed to. She wanted to work more with the design of the tree. So because I am now a graphic designer, so I started to play with artificial intelligence for graphics. And this is the 9 version. And then I was starting to use this from AI, and it was very helpful because in 5 minutes I was able to create a lot of different kind of version of this tree and keeping all the shapes that I wanted to keep because she was approving the shape, but she was saying, okay, now I want a tree. So with the AI, I was able to do it very fast and it was really good. That was the end result. She liked it. Well, then I took down the sign. I took all the old vinyl. I was trying to recycle almost as much as I can. Then I replaced with another vinyl that is here around. I put some 3D acrylic letters. Then Chris took me a picture. I was enjoying being in the rail tracks. And then I did like 8 hours of painting the vinyl because she wanted a specific blue color. So I didn't find a specific blue color in vinyl. So I went ahead and painted everything. But it took me like 8 hours to paint all that. But I was enjoying being outside with the shade of the tree. Then I printed the tree and alpha graphics. I put some vinyl on top. I cut all the seams. The results. And then I replaced the faces. I painted the sign without taking it apart. And now it's there in Willie Street. You go to Willie Street and Livingston. Now you're going to see a new sign. 4 trees. Now I need to do this tomorrow. I only have 1 day. I need to build this structure and a white canvas for the window display. So tomorrow I'm going to be going back.
That's like a deadline.
Yeah. I only have 1 day. That's it. Thank you. Anybody? So Adrian, can you say, you said you used, that, AI program you were using it to help design, you wanted to keep the shape, to play with the shape, but then did you use that?
Yeah.
to Put the tree skin on the shape?
No. You're not able to see what. I was trying to share the website.
Yeah, if you drop out of the program, it'll kill you. So just hit stop share and we'll just reshare the screen instead. Better. So just do share. And I'll just do the desktop one. Just hit share. Because then it'll share it. No, you want to be the whole desktop. Because then it'll share whatever you have. So now if you go back to there, it just shows your whole screen. Like it actually fixes itself. I'm not gonna question the same monster. Because we plugged in HDMI, unplugged HDMI, so like it's.
Yeah. Well, I was using this website. I was trying with stable diffusion, mid journey. It's super fun. It's like I've seen like a lot of things I used to do. Now with AI, it's way faster and cheaper. And like it took me maybe 4 or 5 days to do some drawings, and now it takes 20 seconds. So I need to reinvent myself and a lot of things. But I'm using a tool, and I was working with this.
You pull up the ones that you did of a building. I think that's what Sean's after is. So Adrian made some sketches of a building drawing, like one of your canopies. You know which ones I'm talking about?
Oh yeah.
You know, so Adrian wanted to preview a building made out of trees, which is really intensive to draw. But he could draw a sketch and then tell the image generator to build a tree canopy following the sketch. And it would build a realistic looking image of what he had sketched, only fully rendered and fully reflections and everything. It's crazy. Sorry to put you on the spot if you can't find it, but it's really amazing to see. So yeah.
Yeah. So one thing I saw, like with AI, you can sketch very fast, and say the AI, okay, give me a rendering or put some colors. And I did this as a first try, and then it created this in 10 seconds. So and it was showing all the, if you see, because I just did some wood, vertical wood. I didn't complete the design, but the AI interpreted that it was good and it was right. And this is just a test, a very simple test. And then I was trying with more complex, and it's crazy. Then I was saying like, okay, can you make me a bridge with 3 branches, because this company dedicates of building with trees, and it used to be very difficult for me to draw organic shapes with 3D. And now it's like I don't need to draw anything, just because to present to clients. And this is stable diffusion in 8 seconds. I was imagine draw this in 3D with it's crazy. And I know I am able to dream and show different things and try different things. This is all stable diffusion, and then it's called all the things that
If you've been in Bethel downtown, it's the same company. So the company that made the primary support structures for Bethel Food downtown, the big tree trunks, it's the same company that
and this is an image like this. It looks very real, and it's very fake. Because I put the geodesic dome and earth-shaped like construction. I mean, you give you this, and it's almost real.
Code compliant handrail there?
it has some context.
8 seconds.
But then that was the first steps. But then I was starting to play more. Then I created this, and it's like very, for me, it's very Wisconsin, it's like a Morel dome, geodesic dome. And the cool thing is you can jump from from stable diffusion to mid journey, and it creates the image, because sometimes they get a little bit limited, and they started to do similar things. And so what I was doing is bring it from stable diffusion to mid journey. So give me a different version of this. And when they started to do the same things, I was going from mid journey to stable diffusion, and I was like branching all over. And then from this, this is I'm helping a peacemaker. And now it's like I am playing, and this is now started to pay to have better quality images. But look at this, the quality of these images, like the reflections, and this is like 10 seconds. It's like, and I wasn't able to get this quality of rendering by myself. So, but now, as I make a good sketch and create this, and then I can change and complain and put one piece from here to here. But I don't know, but the good thing is, like, for this company that makes the structures with trees, because now everybody is going to be able to do this, but a few places are going to be able to build it. So images, now everybody is going to be able to create cool images, but how to make the thing, I think we have a long time until the AI can do it.
Other questions for Adrian? Thank you. So yeah, thanks for coming. Like I said, I can give a tour, but we can go around and you can say who you are, what you're interested in, or why you're here otherwise. So Aaron, you're up first.
Oh, sorry, it's I'm Aaron, been with for, I think I got like a 10-year shift now, so.